Okay, my name is Chris, and this is Caledonia Robotics Summer Camp 2020, and this is the third video in this series. The first two videos we were talking about what is the program, the Caledonia Rich program, the resources, and where you can find information. The second video was talking about metal and chassis and wheels and getting started. And this is the third video, and this video is going to talk about more of the gearing structure. So I'm going to scroll through a lot of the things that we've already talked about, and I apologize that we're scrolling. But we went through the nuts and the screws and the bolts, and we were getting through wheels, and we got to this brake, and we were on to sprocket, or for gears. And here we go. So gears. So this is a regular gear set. What you see is you'll see a 12 tooth, you'll see a 24 tooth, a 36 tooth, and a 60 tooth gear set. And these are great, and we have these in the classroom. These are great for on your wheel drive systems. They don't need to be very high strength, but then we have the really great thick high strength ones. So what you see here is you'll also see the same 12 tooth. You'll see a 24 tooth, you'll see a 36 tooth, and a 60 tooth. There, and I don't have all four of them in here, but we have them. And then you'll see some other things in here too, which I'll discuss in just a second. But these are high strength, so you see how they're much thicker. They can handle a lot more torque and a lot more drive. This is a typical 12 tooth gear. They have them in both the high strength, which is the metal, and the regular strength. These are normal gears. Here's a 36 tooth. Here's the 60 tooth, and here's an 84 tooth. So what you're going to use these for gear driving sets and gearing ratios. And we're going to learn about that as we go, but this is really not the video. This is just kind of show you that we have these types of parts. Here is a high strength. So this is the 12 tooth with the pinions in the middle. And these will go onto either high strength axle, or you can slip these inserts in and go to a normal axle, which is an 1/8 of an inch or a 1/4 of an inch. Here's a 36 tooth on a high strength axle. So this is the typical 1/4 inch axle. These are pretty strong, obviously, and you're thinking, oh wow, these are pretty strong. What are these robots supposed to do? But some of these robots will get to 4 or 5, 6 feet in height, and the lift systems to accommodate that can get pretty tricky and pretty torque necessary, and you'll need these types of axles in these high strength gearing ratios to support that type of torque and leverage. Here's a 60 tooth, and here's an 84 tooth, and here you see an insert, and this is a regular axle, an 1/8 inch axle, and then you'll see an insert go through this to accommodate that. Here's some advanced gearing sets. So what you'll see is some racks up here, and you'll see some angle here, and some worm drives and differentials, and these are some of the screws that go along with it. Also, you'll see some inserts for the high strength gearing sets. So this particular one, you could put a high strength gear through or high strength axle through, or you can pop in some of these inserts here, just as you could for the 12 tooth. These are idler fittings or inserts. So if you put one of these in, the gear will just spin around the axle. If you put one of these in, obviously this will stay affixed to the axle and will spin with the axle. Again, this is an 1/8 inch regular strength and the 1/4 inch high strength axles. We have both of those in the classroom. Here's some of your shaft couplers. So if you were to put an axle in this way, an 1/8 inch axle and an 1/8 inch axle, this will extend your axle length. These are called shaft couplers. These are called shaft collars. So if you don't want things sliding on the axle back and forth, you put this collar in and use this little set nut in here with an Allen wrench. And these are called shaft collars. And this here is another type of clamping shaft collar. You put that in, and then you can tighten it down and it will not move. Here is a rubber shaft collar. We don't have very many of these. They're nice. They will move if you're not very careful. We do recommend these as these shaft collars. These are the typical shaft collars that you'll see in the classroom. This is probably 99% of all the shaft collars that you'll see. We don't really have too many of these, and we do have a few of these, but they're not used very often. And then here's a drive shaft bar lock. So what this is if you put an axle through here and you want to connect this to a gear, this will help drive the gear itself. Now this is probably this piece of equipment is probably one of the most important pieces of equipment. This is actually a bearing. This plastic bearing is what you'll put an axle through, and the axle will spin inside this plastic bearing. Now I got to caution you, and the metal has square holes. You don't want to put a piece of axle that's square in a square hole, only because it's just going to click, 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 click as it goes through, and it's going to have a lot of friction. So in order to alleviate the friction, we use these bearings, and these bearings are going to be instrumental to reducing the amount of friction and drive on these robots. These are high strength bearings. See, these pop in. And you'll bolt these bearings down. So the great thing about there's 3 holes, so two of them used for screws and one of them used for the axle. The same with this here. I'm sorry, this was not high strength. This was the 1/4 inch pitch bearings, and these are the high strength. This will have the big center for the 1/4 inch in the middle, and then these 2 holes on the outside are used for your screws. These are bearing rivets, so there's a plastic piece on the outside here and a push piece in here. It pops in, and these are just simple pop rivets. They're not very strong. We don't use them that often. We don't really use them for a lot of things because, again, they're just not very strong. Nuts and bolts are usually what we use to fix things. These are spacers. So you have a typical like 1/8 inch spacer and a 1/4 inch spacer. Actually, they're 4.6 millimeters and 8 millimeters. In width, we use a lot of these spacers in the class, pretty standardized. Here's some nylon spacers. So the nylon spacers look like this. They do the same thing. These are just black and these are white nylon. Here's a Teflon washer. So if you're putting 2 things that rub against each other, 2 metal pieces that rub against each other, you want to put some nylon in between. And if you have 2 pieces of plastic rubbing against each other, you probably want to put a metal piece in between to handle the friction. We talked about the shaft collars here. These are spacers for the high strength axles. And so you see that this width is about a 1/4 inch, 1/4 inch, 1/4 inch. These are called pillow block bearings. So if you have a piece of metal on the bottom here and you need the axle to go across here, these are called pillow block bearings. And these are locking plates. So again, you have a metal insert inside the plastic here. And you can pop these out so you can turn them. But then you have screw hole and screw hole, which you can affix it. And these are usually used to put on an axle to help drive a gear or a sprocket. These are called universal joints or U-joints, and these will connect 2 axles together. So an axle coming this way and an axle coming this way. They don't have to be straight on. They can be at a little bit of a 45 or 50 degree bend, and they will work. Not 90 degree bend. 90 degree bend would be very difficult for these to do, but usually like a 45 or less. If we're talking about motion, if you want to change a 90 degree motion, so you can see an axle coming in from the bottom here, and then it connects with a gear, angle gears here to a cross section. If you need to change the axle drive from one direction to another, this is called a gearbox. Here's some tank treads. So everybody thinks tank treads are really cool, but I will caution you, tank treads on a rubber surface do not work very well. So although we have these, you're probably not going to use them to drive your robot around on the surface of the floor because it's a rubber surface, and quite honestly, these tank treads grip too much on a rubber surface, and these are very difficult to turn. But you would want to use these if you want to pick something up off the ground. They slide up and down very well. So there's some great reasons why we would want to use these, but probably driving is not. Here's an upgrade set to it. So these have a little paddle. So you swap out some of the tank treads and put in this little paddle. And these are very good at grabbing things and lifting things up. Here's some linear slides. So a piece of plastic, and these slide up and down, kind of like a forklift maybe, or a slide left and right if you want to slip things left and right. Here's a turntable. So the turntable spins left and right if that's something that you thought you might want. Here's a winch and pulley. It just pulls in the rope. I'll tell you, it's great going in, but it's difficult to get a rope to go back out. And the last thing is a claw. And the great thing about this claw is it works really well, except for it doesn't open very much. So it only opens maybe 2 inches. it's good for grabbing onto things. It's got a lot of strength on the claw itself, but again, it doesn't open very far. So if you're looking to get big things, it doesn't work very well. So now we're on to sprockets. We went to gears. Sprockets are used for chain. So we have a regular set of sprockets here, 10, 15, 10 tooth, 15 tooth, 24, 40, and 848 tooth. These are great for this chain here, but this is not very strong. These are just kind of a low strength if you just need to move something very simply. Here is a high strength chain. So this actually works really well. Well, I think we're just on the low strength sprockets. So here's the smaller sprockets, just going up to the bigger sprocket size, 24, 40, and 48. And then here's the high strength sprockets. You can see the thickness, right? So you see the thickness between this one and this one here. This is a high strength sprocket with a high strength gearing set, and it's more of like what you saw with the tank treads. And here's the chain for that. Works really, really well. Here's again a 6 tooth, 12, 18, 24, and 30 tooth sprocket. And that sounds like another break time. And that is the end of our parts. At this point, then, we've gone through all the parts. I would have cleared this in probably about 30 to 45 minutes. And it's time to go start building on a square bot. And if you wanted to get started for a camp, this is a great place to go for a basic square bot and learning. This is what I would do typically in the classroom. There's some other things on engineering notebooks we'll talk about later, but these are some great resources. If you have a chance, pause it now and go onto this and take a look at it. Here's a bit.ly short hyperlink for you, and here is the engineering notebook and a great way to get started on that. And with that, day one of the camp is concluded of going through parts, talking about the game. And my name is Chris. It's Caledonia Robotics. If you have any questions, please reach out to us. Thanks for watching.